First open the ANSYS software, select workbench 2020. Now you select fluid flow fluent. Either you can drag it or double click. Select right click geometry, start new design modular geometry. Set the unit as mm, then you select the XY plane, look at sketching, circle, you draw one circle away from the origin, slightly away from origin. Dimensions, correct the dimensions as 100 mm. Horizontal dimension from origin, as 137.5. Now we want to revolve it. Go to create, revolve, select the geometry, sketch 4, axis, you select the plane. You can see the axis with the red arrow mark. You select the axis properly. ZX plane, apply 90-degree rotation. I want to reverse the direction, generate. You want to extrude, select the face, apply it, direction button, you select the plane, you can see the arrow mark. You want to reverse it, reverse direction, apply, you want to reverse the direction, click reversed, generate. Similarly, extrude again. You want to select the surface, select the face selection tool, select the face and apply it. Direction to extrude, to select the plane, you see the arrow mark, apply it, depth is 200. Now we want to create another plane. parallel to the xy plane. For hot water inlet, correct the dimension of the circle. Distance, correct the distance as 137.5. This is drawn in a newly created plane. Now click extrude, apply the sketch, then direction normal, direction vector up to the extend type up to the surface. You select the surface. Apply, generate. Now we want to slice it because it is having some symmetry. There is a plane of symmetry. Properly select the plane of symmetry. Before that, you want to rotate. It is better to keep the diagram in XY plane. Move to create, body transformation, rotate. Select the body, apply. Axis you have to select very carefully. You want to reach it to keep the figure in symmetry in XY plane. So you have to select properly the axis or plane of symmetry. It's not correct. Okay, 90 degree. Yeah, it is correct. Now it is in XY plane. Now we want to slice the figure because we want to do analysis only in half portion because there is a symmetry. So we want to slice the figure exactly at the symmetry itself. For that there is a slice tool. You can see the slice tool. Body, base plane. You have to select the base plane. So you have to select properly the plane of symmetry. Slice, select the plane of symmetry, XY plane, then generate. This you can see the two sliced into two exactly at the symmetry. Now you want to suppress it, suppress one body. For that, select the body selection tool, select the half portion, right click it, suppress body. Now you have to name the face. First select the symmetry, face selection tool, select the face, right click, named selection, symmetry, generate. Select the face selection tool, select the face selection tool, you select it, right click, named selection, apply, outlet. Generate. Now select face selection tool, select the face selection tool, select the face, right click, named selection, apply, inlet underscore cold, generate. Now face selection tool, right click, named selection, inlet underscore hot, generate. Outer surface is considered as bald, that automatically will take, either you can give the name or you can delete, you can leave as it is, it automatically take wall surface. Now we minimize it, update geometry, double click on mesh. There are different methods for meshing. Presently we are adopt for automatic meshing with some inflation. Inflation will, if you input inflation, that will automatically take the boundary values correctly. At the boundary, mesh size will be small. So insert inflation, select the wall surfaces, apply, generate mesh. I can see small meshes, fine meshes near the boundary and coarse meshes at the center. Now you double click on the update mesh and double click on setup, double precision, start. It will take a few seconds. first you have to select the general, it's a pressure based solver. Now you make energy on, then you select the model, turbulent model K omega SST K omega, that will absorb the boundary calculation accurately. Now you go to materials. Materials is given density and density, viscosity, specific, everything is given. You select the material, edit it, all values, edit all values. Because the name is not given, you write name as new liquid. New liquid. We don't know the liquid. It is almost close to water, but it is not mentioned that it is a water. So I am giving name as new liquid. If it is a water, you can take the data from one database. You edit the values, given values. Viscosity 0 point. Change bar create. You need not overwrite it, no. So that new material liquid is appeared on the screen. Now you set some conditions. You select new liquid. We select it as new liquid. Just now we are entered the data. You can change the name as new liquid, new underscore liquid. Boundary condition, inlet condition is given. You can give the velocity, edit the velocity 0.4, then thermal temperature as 293 Kelvin. So unit is mentioned inside, so you have to input the values in that particular unit itself. Apply. Now select the inlet hot condition. So velocity edit to 1.2, then thermal to 313 Kelvin. Apply, close. Outlet nothing is given, so leave it as it is. Symmetry, nothing is mentioned. Wall also nothing is mentioned. Now you have to initialize the calculation. Method, you can use default methods. Controls, also default conditions. go to initialization, hybrid initialization, initialize, default option you are selected. Now you go to run calculation. Number of iterations can be say 5000. Calculate. You can see the residuals. Default residual value is 0.001. If we reach that particular value, the solution is considered as converged. So before reaching within 100 iterations, it is converged. Even though you have input 5000, that's not required, only 50. 100 iterations, it is converged. Now you go to control contour, results contour, velocity contour, display. So you have to select the values. So this is the velocity variation. Right click it, you can save it. This is the temperature variation. You just click on the screen, save picture, click save picture as JPG and save the files, temperature variation and velocity variation. Okay, thank you for watching.